Have you ever felt a tiny shock when touching a metal object? That's static electricity at work. This fascinating phenomenon is not just about annoying shocks. It has critical applications in technology, industry, and nature. Static electricity occurs due to an imbalance of electric charges in materials. This imbalance often happens through the triboelectric effect, where materials transfer electrons through contact. This results in one material gaining a positive charge while the other becomes negatively charged. Electric charge is essential for understanding this phenomenon. It comes in two types, positive and negative. Protons hold positive charges, while electrons carry negative charges. Objects become charged by gaining or losing these electrons. Let's explore 4 key properties of static electricity. First, charge induction allows a charged object to influence a nearby neutral object without direct contact. For instance, bringing a charged object close to a neutral conductor causes electron repulsion, leading to the neutral object's own charge. Next, we have charge conservation. This principle states that the total electric charge is constant within an isolated system. When static electricity is created, the sum of positive and negative charges remains unchanged, ensuring predictability in electric interactions. Discharging mechanisms illustrate how static electricity seeks balance. It discharges when a charged object contacts another object of opposite charge. This can result in a small spark or, on a larger scale, lightning during a thunderstorm. Finally, every charged object generates an electrostatic field, impacting other charges nearby. This field's strength decreases with distance, but can still exert significant influence on other charges. Static electricity affects our daily lives through various applications. For example, in households, it helps dusters and vacuum cleaners attract debris. Industries employ electrostatic painting for smoother finishes and use photocopy machines that rely on electrostatic charge to function. In the environment, static electricity is manifested dramatically as lightning. It results from massive electrical discharges during storms and plays a role in atmospheric electricity, which is vital for weather forecasting. While static electricity can be beneficial, it poses risks in places with flammable materials. Electrostatic discharge can damage delicate electronics, making ESD control critical in manufacturing. Industries also implement grounding techniques to prevent static-related fires. In conclusion, static electricity is a powerful phenomenon intertwined with everyday life and technology. Understanding its properties not only helps us harness its benefits, but also mitigate risks. The next time you feel a small shock, remember the incredible science behind it. Embrace the wonders of static electricity in your everyday adventures.